It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. Welcome back, everyone. To this explainer, today marks a massive pivot point in the SWE4304 module. You've officially finished your Assessment 1 blueprints, which means you spent hours upon hours capturing detailed requirements, mapping out those complex entity relationship diagrams, and meticulously normalizing your data to third normal form. Honestly, that was a lot of heavy lifting in the conceptual space, but it's really about to pay off. Because today we are officially launching the Assessment 2 build phase. So you might be wondering, your blueprint is finished, but how do you actually build the database? Well, today we need to completely shift our mindset. We're done drawing conceptual diagrams, we're done writing plain English business rules that rely on human interpretation. Instead, we're moving into the world of writing executable, highly precise code. And remember, computers don't understand nuance, right? A database engine isn't going to guess what you meant. Literally, if a single comma is out of place or a data type is misspelled, the build fails. Precision is everything from here on out. Here's our roadmap for today. We'll start by launching Assessment 2, then cover data definition language foundations, selecting MySQL data types, and enforcing rules with constraints. After that, we'll establish our professional scripting standards, and finally, get into building Schema version 1. Let's kick things off with Section 1, launching Assessment 2. The build begins. Okay, let's dive right into this. Up until week 7, your focus was entirely on logical and conceptual design. But starting today, in week 8, we take those logical ERDs and translate them directly into executable MySQL scripts. Think of your Assessment 1 evidence as architectural blueprints. You've drawn the walls, the doors, the wiring, and now it's time to pour the concrete. In database terms, those entities you drew are about to become physical tables. Your attributes will turn into specific columns with allocated memory, and those relationship lines you painstakingly mapped out, they'll be translated into hard-coded foreign keys. We are using your final signed-off relational schemas as our exact guide for construction. Moving right along to Section 2, Data Definition Language Foundations, the builder's tools. To actually pour that concrete and build your tables, you need the right tools. Enter DDL, or Data Definition Language. DDL is the specific SQL vocabulary you'll use to define, construct, and implement your relational model structures, things like schemas and tables. Now, it's absolutely crucial to distinguish DDL from DML, which is Data Manipulation Language. With DDL, we're not asking the database analytical questions or inserting user records just yet. That comes later. DDL is strictly about building the physical containers, the actual architecture that will eventually hold your data securely. These core commands are simple but incredibly powerful. During hour 1 of your lab this week, you're going to establish your build order using these exact statements. You'll use create schema to make your overarching database container, and create table to build the individual relations based on your ERD. Crucially, you'll also use commands like describe to view your column structures right in the terminal to verify your data types applied correctly. And you'll use show create table to validate that the database engine built exactly what you intended behind the scenes. These commands are fundamentally the verbs of your Assessment 2 workflow. Next up is Section 3, selecting MySQL data types. Choosing your materials. So here's the thing. In Assessment 1, we were pretty forgiving, right? You might have just labeled an attribute as text or number, and that was perfectly fine for a conceptual model. But a relational database engine, it demands absolute precision. The engine allocates specific amounts of disk space and memory and applies strict validation rules based entirely on the data type you choose. You absolutely must translate that generic logical text into specific types like varchar, and those conceptual numbers into highly precise types like int and decimal. You have to define clear, optimized attribute domains for every single column in your design. You'll use int for whole numbers, which is standard practice for auto-incrementing primary key IDs. You'll use varchar for variable length strings like names or emails. And remember, you actually need to specify a maximum length for those, like varchar 50. You'll use date to store calendar dates. And, super importantly, you will use decimal for exact financial figures. We use decimal instead of float because we literally cannot afford rounding errors when dealing with currency. Choosing the right data type is your first line of defense. It ensures data integrity the second a user tries to insert a row. Let's look at Section 4, Enforcing Rules with Constraints, the physics of your building. Now we reach a major shift. We've defined what the data is, but now we must strictly define how the data must behave. And these constraints, they are mandatory. Think of them as the physics of your building. Gravity doesn't take a day off, and neither should your data rules. You have to explicitly declare your primary keys to uniquely identify rows so no two records are identical. You need foreign keys to link your tables and enforce referential integrity, meaning you can't have an order pointing to a customer that doesn't exist. You'll use not nulls so critical data, like a login email, can't be left blank. Unique prevents duplicate values where they shouldn't exist, and check constraints let you enforce business logic right at the database layer, like a rule that says a product's price must always be greater than 0. This is exactly how you make your Assessment 1 business rules fully executable. Which brings us to Section 5, Professional Scripting Standards, Building Codes. Let's talk about how this translates into your actual workflow. We aren't just clicking around randomly in some graphical interface. We are adopting rigorous, professional scripting standards. This is the script-first workflow you'll be practicing heavily in hours 2 through 5 of the lab. Step 1 is writing those precise create statements we just talked about. Step 2 is adding professional comments and sticking to consistent naming conventions. Trust me, your future self and your assessors will absolutely thank you for that. But step 3 is the golden rule. Your script must run cleanly from scratch. It needs to be totally reproducible. If you completely drop your entire database, you should be able to click Run on your script and generate the exact same schema version 1, from top to bottom, without a single manual tweak or error. Finally, Section 6, Building Schema version 1, Pouring the Concrete. By the end of this week, specifically in hour 6 of your lab, you have some very clear deliverables. You need to actually build Schema version 1 in MySQL. You need to validate it using those DSC and show create table commands. And finally, you need to export and commit your build evidence. Practically speaking, this means saving your clean, fully functional .SQL file, maybe grabbing your terminal output to prove it executed without a hitch, and committing that directly to your version control or submission portal. This right here forms the foundational layer of your Assessment 2 portfolio. To help you get there, please rely on the readiness checklist for your 01underschema.sql file. Consider this your final call to action for the week before you submit a thing. Ask yourself, have you chosen the absolute most precise data types? Are your primary and foreign keys correctly linked with the right names? Do you have not null applied wherever it's necessary? Honestly, going down this checklist ensures you're producing a clean, submission-ready script that fully realizes your Assessment 1 design and actual code. I want to leave you with this thought to really emphasize why we're doing this. A clean script today prevents a database disaster tomorrow. The rigorous syntax work you are putting in right now, defining tight constraints, selecting the exact data types, and mastering DDL, is exactly what stops terrible data from breaking your software applications down the line. Catching an error at the database schema level, that saves countless hours of debugging application code later. It is literally the hallmark of a professional software engineer. So, as you head into the lab for week 08, ask yourself, are your DDL scripts ready to build an unshakable foundation? Grab those finalized ERDs, fire up MySQL Workbench, and consult your week 08 lab documentation if you get stuck on the syntax. You've got all the tools you need to completely crush the start of Assessment 2. Have a fantastic week of building.